Ansys Fluent. So in this diagram, we can see that here the exhaust system, this is the manifold or silencer. We told both. So this is the manifold inlet and outlet. We find out the exhaust system. This is the manifold any car, any bikes. So we find out the heating. What is the area of the heating will affected on the silencer or manifolds. Okay, this is the T section pipe. So we find out the T section pipe erosion rate here. Solver capability CFX. This is the CFX, the Ansys CFX solver. Ansys CFX software is a high performance, generally purpose fluid dynamic program that engineers have applied to solve wide ranging fluid flow problem. At the heart of the CFX, it advanced solver technology, the key of achieving reliable and accurate solution quickly and robust design. Because we can see that the turbine blades analysis, very complicated geometry will be analyzed in this platform CFX. Then this is the Pelton turbines wheels, the turbines blades, and centrifugal pumps, and complicated geometry can be analyzed with help of the CFX platform. Now we discuss about the Ansys M. So yesterday we have already discussed Ansys M and Ansys Discovery. So this is a new features which is developed in the Ansys software, Ansys M. So this is similar to the Ansys. Okay. So we find out the static, structural, and CFD all platform available in Ansys M. And then next, multi-physics Ansys M, in which multi-physics means up to 80% of cost of the product developed is determined by the decisions you make the early in the design process. Upfront simulation is digitally exploring design concept. Okay, then concept and testing critical design choice early in the product life cycle using the simulation. And M is an integrated solution for the 3D solution, encompassing the breadth of the Ansys physics in a single modern user environment. On this platform, we can do, here we can see that this is the chassis of bike frame. This is the bike frame. This is the heat exchanger. This is the pipeline. Okay. So this is the valve, butterfly valve. So numbers of analysis we can do this Ansys M. Yeah, this is the very important COVID-19. Yesterday we have a small discussion about the COVID-19. So social distancing, wear masks, and ventilator inhaling and drug delivery. So nowadays, an N95 masks available in your market, medical stores, and face shield cover are available. These products will be analysis. These products have already analysis with platform on the Ansys. So we can see that this is the social distancing. So distance of 1 meter and 2 meter away. Here the cup simulation, 1 meter distance, 2%. So the marks wear by the 1%, and this is the simulation of the cup simulation. Okay, this is the cup simulation analysis with the 1 meter distance. When the another person stand 1 meter distance, between the distance 1 meter, then one person cuff analysis produce here. So how many velocity produce of the cup? So amount of the velocity we can see here in this analysis. So our marks is good or not. So in this figure we can see that the marks where a person, then cup velocity is high, so amount of cup spread outside the environment, that is not good for the another person, because there's more chance to the positive, corona positive. So the fitting of the marks, so this is the clear seen that here the yellow strip on the marks with fitted on the nose. Okay, here no strip provide. So this is the our bigger failure to the analysis. Okay, so here when a put up strip on the nose, so we can clear seen that no red color zone here provide, but we here can clearly seen red region provide because here the velocity of the cup is very high. Here reduce the velocity of the cup, so this marks fitting is very good. So nowadays the N95 marks beer for reducing the coronavirus effect. If you use without N95 marks, with it not capable to uh, reduce the effect of positive coronavirus. Okay, so every person to use this step types of marks with fitted or your nose. Okay, so here another example we can see that uh, cuff analysis, a person during the cuff analysis outside of the mouth. Go to the next slide. Next, COVID-19 isolation ward. Isolation ward, negative pressure room. This is the very important purpose isolation ward for the negative room. So nasal and oral discharging 100 CFM. Okay, 100 unit of the density here indicate the 100 CFM. So down lower here the ventilation provided, a person rest on the bed. This is the patient, and this is the ducting. So here the design a negative pressure room to minimize the contamination. So uh, design the negative pressure room. So this is design is failure because the air circulated around here the patient, surrounding the patient. So this is the very lower because the value of the CFM is very high, 500. In this figure, the 500 we find out the value of the CFM. Okay, so vacuum is generated in surrounding the uh, patient. But here we find out the design of the duct is good because the person mouth is spread the cuff and ducting inside, so spreading the amount of the CFM is 100 CFM. So reduce the amount of CFM will be reduced. Then this is the negative pressure. So we find out the negative pressure in this help of the software. We can do any analysis on this platform of the Ansys. Okay, so this is the analysis related to the COVID-19. So now we have already
Uh,
finished
Sir,
our.
sorry to interrupt you in between. Sir, what is the full form of CFM? What is this CFM?
Actually, sir, CFM is the ventilation system, is a unit of the vacuum. So this is the high lower capacity. This is the high lower capacity of vacuum. Okay, sir. Or this CFM value is more than, so negative. If CFM is high, CFM is high. Uh, hello, if CFM value is high,
Yes,
so
sir.
this
Yes, sir.
is a CFM is known as the cubic foot per minute. CFM is known as the cubic foot per minute. This is related to the compressor. If this is related to the compressor, cubic per minute is a volume. So here the volume of the negative discharge is very high. So this is not good for the patient. And another patient distance the 1 feet and 2 feet, 1 meter and 2 meter distance between the two bed. So more chance to the positive of another person. So we want to reduce the CFM value. So when the pressure is very minimized inside the room, then another patient more reduce the chance to the corona positive. Okay, sir.
Okay, okay. Thank you, sir.
Okay. Then now we have okay. Now we have discussed about meshing. So why we require the meshing inside the Ansys software? So what is the meshing? So meshing is an integral part of the engineering simulation process where complex geometry are divided into the simple element that can be used as a discrete local approximation of the larger domain. The mesh fluence the accuracy convergence and speed of the solution. So here we can see that the tetrahedron and swap meshing. Okay. So meshing required. Why we are necessary to the meshing? Meshing is clearly speed of the solution. Meshing will be increase speed of the solution. So we are required the meshing. Meshing is an integral part of the engineering simulation process where complex geometry, because geometry is very complicated. So with help of the meshing, we complicated geometry divided into the simple elements and nodes forms. So elements and nodes form, then we find out our solution is very fast with help of the meshing. Okay. And type of meshing, now we direct go to the Ansys software. So we discuss about which types of meshing, fine meshing, medium meshing, and coarse meshing. Okay. So first of all, this is our last slide of our presentations, nodes and elements. Nodes and elements, this is the diagram. We clearly see that this is a triangle, this is the square. When three edges, one is one is, two edges, and three edges. When two edges meet, then create the one nodes. Okay, two nodes, three nodes. Numbers of nodes inside the triangle, three nodes. Then make a one element and produce the one triangle that is known as the element. When three nodes meet with edges, then create the one elements. Okay, here this is the quad elements. Here the one, two,